Working hard is not enough. Nearly everyone has been taught that hard work is the ultimate ingredient for success. Yet decades of psychological research reveal something unsettling. People often work longer hours, sacrifice more energy, and stay constantly busy without making meaningful progress. The problem isn't laziness. It's that the human brain doesn't reward effort as much as it rewards effectiveness. This misunderstanding shapes careers, relationships, health, and even happiness. The belief that effort alone guarantees results sounds logical, but biology tells a more complicated story. Your brain isn't designed to measure how hard you're working. It's designed to conserve energy while pursuing rewards. Throughout evolution, unnecessary effort was costly. Wasting calories could threaten survival. As a result, your nervous system constantly evaluates whether the effort you're investing is likely to produce a worthwhile outcome. That's why working harder can sometimes make you less productive. Psychologists call this the effort heuristic. It's a mental shortcut where people assume that greater effort automatically means greater value. If a project took weeks to finish, it feels more important than one completed in a day. If someone stays late at the office, they're often perceived as more dedicated, even if they accomplish less than someone who leaves on time. The brain confuses visible effort with invisible effectiveness. Behavioral economist Daniel Kahneman spent decades studying how people make decisions. His research showed that the mind relies on quick judgments rather than careful analysis much more often than we'd like to believe. Effort itself becomes one of those shortcuts. It feels convincing because it's easy to observe, but outcomes don't care how difficult the process felt. This becomes especially clear in neuroscience. Every decision you make depends on limited cognitive resources. Attention, working memory, and self-control all draw from the same biological systems inside the prefrontal cortex, the region just behind your forehead, responsible for planning, reasoning, and complex thinking. That system tires. Not because you've reached some fixed daily limit, but because prolonged mental effort increases fatigue signals throughout the brain. As attention declines, your ability to notice mistakes, solve problems creatively, and regulate emotions begins to weaken. You're still working. You're simply working with lower quality thinking. This explains why adding more hours often produces diminishing returns. Beyond a certain point, each additional hour contributes less than the previous one. Economists have observed this pattern repeatedly across different industries. Productivity rises with focused work, but eventually plateaus and can even decline despite longer hours. The relationship isn't linear because the brain isn't a machine that produces identical output every minute. Biology imposes limits. Stress makes those limits even more obvious. When deadlines pile up, your body releases cortisol, often called the stress hormone. In small amounts, cortisol helps sharpen attention and prepares you to respond to challenges. But when stress becomes chronic, elevated cortisol begins interfering with memory, learning, sleep quality, and emotional regulation. Neuroscientist Robert Sapolsky has spent decades studying how chronic stress changes the brain and body. His work shows that prolonged stress doesn't simply make you feel exhausted. It changes how efficiently your brain processes information. You may interpret this decline as needing to work even harder. In reality, your biology may be asking for recovery instead. This creates a trap. The harder performance drops, the more effort people often invest. The more effort they invest without recovery, the more performance declines. It becomes a cycle that feels productive while producing surprisingly little progress. Modern workplaces sometimes reinforce this illusion. Busyness has become a status symbol. Full calendars, overflowing inboxes, and endless meetings create the appearance of importance. Yet research on knowledge workers consistently finds that interruptions fragment attention, forcing the brain to repeatedly rebuild its focus. Cognitive scientists refer to this as attention residue. Part of your mind remains attached to the previous task, making it harder to fully engage with the next one. Even brief interruptions can reduce the quality of thinking for much longer than most people realize. You're not just losing minutes. You're losing mental depth. Learning follows similar principles. Neuroplasticity, the brain's ability to reorganize itself by forming new neural connections, depends less on repetition alone than on deliberate, meaningful practice combined with rest. During sleep, the brain strengthens useful neural pathways and removes less important information. Matthew Walker's research on sleep demonstrates that memory consolidation largely happens after learning, not during it. In other words, improvement often occurs while you're resting, rather than while you're practicing. Hard work without recovery interrupts the very biological processes that transform effort into skill. Habits reveal another important insight. Behavior scientist BJ Fogg argues that lasting behavior change depends less on motivation than on designing environments that make desired actions easier. Motivation fluctuates naturally because it's influenced by emotions, stress, sleep, and countless biological factors. Systems remain. This is why two people can appear equally hardworking while achieving dramatically different results. One constantly relies on willpower. The other removes unnecessary friction, simplifies decisions, and protects attention. The difference isn't character, it's architecture. Even emotions shape performance more than most people realize. Psychologist Ethan Kross has shown that the way people mentally frame stressful experiences changes how effectively they regulate emotions and solve problems. The brain isn't simply reacting to reality, it's constantly interpreting it. Two identical workloads can produce entirely different outcomes depending on how those demands are processed internally. That realization changes the meaning of hard work. Effort is still necessary. Scientific research doesn't suggest otherwise. Practice matters. Persistence matters. Discipline matters. But none of these operate independently from biology, cognition, attention, sleep, stress, and environment. Hard work is an ingredient. It isn't the recipe. The deeper lesson emerging from neuroscience and behavioral science is surprisingly simple. Your brain doesn't reward effort for its own sake. It rewards effort that aligns with how the brain actually learns, adapts, remembers, and makes decisions. That's why working hard is not enough. The real question isn't how much energy you're spending, it's whether your biology allows that energy to become progress.